A very warm welcome to all the students from Olympiad Success family. So today, students, as you all know, we are here for a demo interaction program for Level 2 Science Olympiad, right? And once again, I would like to congratulate all of you to making it to the Level 2. I know it takes a lot of effort and preparation from your end, and to clear and to make it to the Level 2, there are thousands and lakhs of students appearing for these examinations. And for you all, I truly agree, like there is a high level of competitiveness and the competition has increased as compared to our times, like when we had really less competition. But so you kids are doing really wonderful, and the main purpose of these classes, is to make you stand a step ahead of your peers. So in terms of your conceptual understanding and practical application of the concepts, basically. So like in these Level 2 classes, our focus would be, because you already know everything, right? So we won't be discussing all the topics once again in detail, but then what we would be doing is, like, we would be revising the concepts, we would be revising the topics, and then we would be taking up the questions from each of the topics. So these would be previous year questions, and these would be really, helpful for you to take the Level 2 examination. All right, so we would make sure that your concepts are really clear, and because in Level 2, the major difference between Level 1 and Level 2 questions is regarding the difficulty level of the questions, right? And so why Level 2 questions are difficult? Can anybody tell me? Okay, Aradhya. Yes, Aradhya. I'll just unmute you.
Ma'am, I think because all the students who know how to do the questions in Level 1, so they need to make a competition and bit tough. So they do questions tricky in the Level 2, so that only few children can have full marks or can gain more.
Absolutely, exactly, yes. So the questions are really tricky. So basically tricky in terms of the concept. So if you can apply your concepts, your understanding well to the questions, the question automatically becomes easier, right? So if you know your concepts well, so the question automatically becomes easier for you. So right, Aradhya, and so in these sessions would be dedicated to strengthening your concepts and taking up as many questions for your practice. So students, for today's session, especially since this is a demo session, we have we would be following this method. Like, first of all, there would be an introduction by a mentor, then there would be a presentation by Rajan sir. After that, I'll be taking you through the tour of the platform. Post that, we would be having a short question and answer round. So if you have any doubts, queries related to this course program, you can let us know by writing down your question in the chat section. And after this question and answer round, we will be starting with the demo session, for which you all are here, right? So this would be for the demo session, if I talk about, so that particular part would be of around 40-45 minutes. But then, like, once we start the classes, this would be for 1 hour and 15 minutes. Okay. So now I would like to invite Aishwarya ma'am. So Aishwarya ma'am has been associated with us for now, and she has been taking classes with us. So welcome, Aishwarya ma'am, and why don't you provide a brief introduction about yourselves to the students?
Thank you, ma'am. Thank you. Good evening. Hi, good evening, everyone. My name is Aishwarya, as Aarti ma'am has already told you. I am from Delhi. I have an MPhil in botany from University of Delhi, as well as a B.Ed degree. And I have been teaching for competitive exams for the past 4 years now. And mostly my expertise will lie in the subject of science. So I've taught at all levels. I've taught at colleges, schools, institutes, classes from 7th to 12th, everything. So when we start our session, my main agenda would be to have an interactive session with all of you so that we can learn new things in a fun way, right? And I would like all of you to ask as many questions, as many doubts as possible, so that I understand how much how much you are grasping the topic here on our live sessions. And we will, of course, learn together, clear all our concepts, and find tips and tricks to solve the questions much more easily. So welcome all of you.
Yeah, thank you so much, Aishwarya ma'am. And students, I'm sure you're going to love our classes. And as Aishwarya ma'am mentioned, so you have to be as interactive as possible, because until and unless you ask questions, like your concepts wouldn't get that strong, because it's always good to ask questions. Even if you're having a small doubt, make sure you ask that. Okay. And now, Rajan sir, over to you for the brief presentation.
Sure, ma'am. Let me share my screen. So, welcome students. Welcome to the demo interaction program for grade 7. This is for like level 2 course. So, firstly, let me tell you about us, about Olympiad Success. So, Olympiad Success is India's largest online preparation platform for Olympiad exams. We have Olympiad live classes. We also have School Plus program. So, in School Plus program, we offer 8 courses that are mathematics, English, science, logical reasoning, communication, spoken and written both, Vedic maths, as well as coding. What else, students? We also offer online CBSE plus Olympiad classes for grade 6 to 10 and one-on-one preparation classes for International Mathematics Olympiad like SESMO, CMO, HKIMO, TIMO, Math Count, US Math Competition, Math Kangaroo, and PRMO. Now meet the rank holder for session 21-22. So many students in Olympiad success got international ranks. Okay. Now students, about this course. So there will be around 20 students in the class and the classes will be conducted on Zoom platform only. So there will be 4 sessions per week. The days will be Monday, Wednesday, Friday, and Saturday. And the class timing will be 5 p.m. to 6:15 p.m. Okay. Now, what we are going to do in this course, like this is a level 2 course. So we are going to have topic-wise quick revision of chapter. And after each and every chapter, we are going to discuss previous year level 2 questions. Okay. And students, you will get reading material and practice question, which is will be available on the dashboard of Olympiad Success. And with this course, you will also get a practice test, mock test, especially for level 2. Okay, level 2 previous year questions. Okay. Now students, the live course syllabus I will share within the chat box. So the fees for this course is 4,500 and there will be 20 sessions in this course. The payment link I will share within the chat box. The fee include online classes, daily reading notes and exercises, practice of previous year level 2 question. And like I said, you will get access to the Olympiad Success platform for content and mock test. Okay. And I think results are already out, but in case like if anyone not got selected for level 2 exam, we are going to refund the fee after deduction of 10%. But you need to share your roll number with us, okay, while enrolling for the course. To join this course, you need a laptop with good internet speed and headphone. And as many of you already applied in level 1 exam, you know like you need to prepare for the Olympiads. So you need to spend approx 2-3 hours every day to cope up with the curriculum, okay? Now, the live classes for this course, we are going to start from 11th of January. And currently, we are having students from 3,800 schools, and we are catering in 35 plus countries. So this is about this course, students. Now, Artima will give you a tour of Olympiad Success Dashboard. And after that, if anyone have any doubt, query, we will take that. Okay. So over to you, Artima.
Yeah, thank you so much, Rajan sir, for a brief presentation. And now let me share my screen. So students, like once you enroll to this program, you would be getting your credentials to log into the platform. Okay, what you have to do is you have to go to the website olympiadsuccess.com/login, enter your credentials, that is your email and password, and click on the sign in button. You would be redirected to the profile page wherein you have to complete your profile so that you can move to other sections on the dashboard. So the first important thing which Rajan sir had mentioned was access to the content. Okay, so you can access the content by going to the live classes page, and here you have to select your subject. So it is Science Olympiad. You have to select the topic for which you would want to access the content. So let's say nutrition in plants and animals. So here, as you see, reading material, practice questions and answer keys. So I'll just click on any one of the links. So let's say if I click on reading material, so the reading material for that particular topic, that is nutrition in plants and animals, it would open up. Okay, so okay, it has not opened, and maybe like it's waiting. My internet speed would be slow. And similarly, like for practice questions, you have to just click on that and your practice questions will open up over here. And similar would be the case with the answer key. So as soon as you click on this, the answers like for the questions which were asked in this set, okay, so would be displayed in this. Okay, so you can mark your questions and check your answers. Then we have the schedule also. So If you click on the schedule button, the complete schedule would be displayed, wherein we would be telling you like what we would be taking up in each of the classes. I'm so sorry, like it's not getting opened. This is due to the internet connectivity issue. So what happens is like for all the 20 sessions, as you all know, there are 20 sessions in this course. So what we would be taking up in session 1, session 2, everything would be mentioned very clearly. And then we have the holiday calendar, wherein we would be mentioning the days on which the classes will not be conducted. And finally, the Zoom meeting ID and password. So here your meeting ID and password will be displayed, using which you can log into the classes. And then the next thing is access to level 2 mock test work. So to access those, you have to click on the worksheets, click on science level 2 mock test. And here, if you see, like all the 10 mock tests would be available for you. You have to just click on the take exam button, take the examination, and finally you can check your performance or the answer keys by going to the performance tab, and here select the subject and click on the view button, and you can view your answer keys. Okay, so that is all about the platform. You would be getting the access as soon as you enroll to this program. Okay, so now if you have any doubts, queries, you can write it down in the chat section and we can take up all of them one by one.
So students, do anyone have any doubt, any question? No? Okay. Okay, let me ask you one question. So can you tell me the days for which we're having the classes? You can write in the chat box. You can write in the chat box. No, 20 is the number of session. I've asked the days on which we're having the classes. Tuesday, Thursday, Saturday. No, Arif, that is wrong. Arnav, that is wrong actually. Monday, Wednesday, and Friday, Saturday. Monday, Wednesday, Friday, Saturday. Correct. The days are Monday, Wednesday, Friday, and Saturday. And what is the timing for the classes? 5 to 6:15. Yes, correct. 5 to 6:15. Okay, so students, do anyone have any query or any doubt, or everything is clear? No doubt. Okay. So shall we start with the session? Okay, Aarti ma'am. This is second level, right? Yes. Raghavendra, this is the course for level 2. So we are going to do a quick revision of each and every topic, and then we are going to discuss level 2 previous year questions in this course. Do anyone have any other query? Okay. So Aarti ma'am, I think we can start with the session.
Yes, absolutely.
Okay. So over to you, Aishwarya ma'am.
All right. Okay, so before I start, I would just like to request all of you to please switch on your videos. It's nice to see all the faces on screen. I see only a few people with their cameras on. Can you please switch on your videos if possible, everyone?
Yeah, so students, I would like to give you an update. Basically, like Rajan sir had mentioned during his presentation also that we have been conducting these live classes for many years now, and we would be starting our next batch of classes from February or March. I believe March we would be starting the classes. And there is this important point coming up, like we would be enrolling only those students who turn on their camera, because you know, the level of sincerity does not come until and unless the camera is turned on. Okay, so that is one of the very important points which we would be adding up in our presentation also, and that would be a must point for everybody, otherwise you won't be able to enroll for these classes. Okay, so as Aishwarya ma'am mentioned, please turn on your videos, because it is really helpful for the mentor also, you know, because teaching blank screens, it's very difficult. Thank you so much, kids who have turned on their videos. Really thankful.
Thank you, ma'am. Actually, once they've switched on their videos, I now know that I've taught a few of them before also. Otherwise, I couldn't see them.
Right.
All right. Okay. I'll just share my screen. Just give me a minute. Okay. All right. So today we're going to discuss the chapter light, right? We will do a quick revision. So that is what the session will comprise of, revision and then the question answer round. All right. So we're just going to skim through the basics of light. Of course, I'm sure everybody knows what is light. So what is light? Light is a form of energy, right? Anything else anybody wants to tell me about light? Whatever they know about light, you can put it in the chat box. We know light is a form of energy. And of course, it is helping us to see things. So whatever is visible to us, right, that is because of the presence of light. So even whatever we are seeing around us, that is because that object is emitting out some kind of light, and that light is going into the eyes. And because of that, we can see that object. Very good. So light usually travels in a straight line, and light can behave both like a wave and a particle. Very good. Photosynthesis happens in the presence of light. Yes, light follows a rectilinear propagation. Correct. So light is a form of energy in which light moves or travels in a straight line, and we call that as a rectilinear propagation. Rectilinear means we've all done motion. Rectilinear means it's traveling in a straight line, right? What about the speed of light? Does anybody know about the speed of light? I'm not asking the value, but what do you know about the speed of light? Anything that you know? Yes, Aradhya, can you put it in the chat box? Okay. All right. Approximately, yeah, 3 into 10 raised to the power 8. But what is the special feature about the speed of light? The value is correct. But what do we say about light? The speed of light? Light years. Why do we say light years? Light has the fastest speed. Yes, especially when we are in vacuum. Very good, Ahan. So normally in whenever we're talking about that, in space, that some planet or a star or any kind of asteroid is this many light years away from us, that means that is the fastest speed it can travel towards us. That is the fastest way in which we can measure the distance or any time that anything will take to reach our eyes, and it will be visible to us. So normally, I'm not sure if you've observed or not, normally if there's a thunderstorm, you see the lightning first and then you hear the sound later, slightly a few seconds later, right? Because light will travel the fastest. Okay, very good. Moving forward. So we know light is a form of energy. Second, we know that light can either give you a shadow or a reflection depending on what it is falling on. So if it is falling on an object, the object will have a shadow, or it can create a reflection. We will talk about this in detail in a little while. Now, when we are talking about the motion of or the pathway of light, everybody has already told me that light travels in a straight line or it follows a rectilinear propagation. That is usually demonstrated by this experiment. Can someone explain this experiment to me? You can raise your hand. Yes, Aradhya. What is this? You can mute. Yeah.
Ma'am, this experiment is about, like, we have lighted a candle and there are three cardboard papers, and we have made holes in them at the same space, so that we can see through our eyes we can see that lighted candle. And if the spaces would be the gaps would be on the different spaces, so we could not see through them. This shows that the light travels in a straight line.
Correct. So we've taken 3 cardboard pieces and we have created, or we've made a hole at the same distance or at the same, from the, let's say from the top or from the bottom, at the same point in all the 3 cardboards. And through the cardboard holes, we can see the candle. So you can see the light of the candle straight coming to your eye. If I move either of the cardboard, either cardboard B, A, or C, I will not be able to see the light of the candle. So this demonstrates that the light travels in a straight line, and light takes the quickest path between any 2 points. That is why the speed of light is the fastest. Okay. Now, there are two sources. Quickly, just we'll go through this. I'm sure you know all of this. There are two sources of light, normally depending upon where it is coming from. Either we can have a natural source of light or we can have a man-made source of light. Natural sources of light would be sources which have a light of their own, right? So like the sun and the stars, they can emit light on their own. So that is why they are known as the natural sources of light. And of course, they are naturally occurring in space. And man-made or artificial sources are the sources that has been created by man. So electric bulb, tube light, fire, candle, they are all man-made sources of light. Firefly, insect, natural. Yes, Kumud, good. That's natural. Any doubt here, anyone? No doubts? Okay. Shall we move forward then? Yes, Tejashree, even bioluminescence. That would be natural source of light. Good. Okay. Now, depending upon whether an object can emit light, whether it is natural or whether it is man-made. If it is emitting light of its own, then they are known as luminous objects. For example, the sun and the stars, they are all luminous objects. Okay, let's say a burning candle. Candle is also a luminous object. Fire is a luminous object. A firefly insect, or let's say any organism that can, or a tube light or a bulb, anything that is emitting its own light, whether it's natural or whether it's man-made, that object is known as luminous. Okay, and the opposite would be non-luminous. Any object that does not have its own light or is not emitting light on its own are all non-luminous objects. That means Earth is non-luminous, trees are non-luminous, yes, moon is non-luminous, book, pencil, human being, we are all non-luminous objects. Got it? Okay, so can someone tell me how do we see the light of the moon then? Moon is non-luminous object. Okay, it doesn't have a light of its own. Yes, Kumud?
We can see moon as like when the earth, when the light of the sun is reflected by the moon, the light which is reflected hits our eyes and we can see the moon.
Correct. So basically the light that is coming from the sun, that is getting reflected. Okay, so they reflect the rays from the sun and eventually that light will reach us and we can see the moon. That is why during a lunar eclipse, we do not, or let's say a solar eclipse, we see the sun or the moon in a different light because it will come in, the earth will come in between the sun and the moon. That is during the lunar eclipse, right? Okay, good. Moving forward. All right, so there are some examples of luminous and non-luminous objects given here. So here we have all luminous objects, the sun, fire, earth, bulb, and non-luminous objects, everything from your pen, your clipboard, pencil, brush, moon, they are all non-luminous objects. Okay. Okay, who will tell me, just quickly write down in the chat box, out of the following, which objects are luminous and which are non-luminous? Quickly write down luminous and non-luminous in the chat box. Okay. Rat, earth, apple, what are they? Luminous, non-luminous? Okay. Candle, luminous. Okay, yes. Sunlight and torch, luminous. Okay. Non-luminous, rat, earth, and apple. Okay. Okay. Great. Good. So the candle, the sun, and the torch, they are all three are luminous, whereas the rabbit, the earth, as well as the apple, they are non-luminous. Okay, now depending upon how much light can pass through an object, we have three types of objects. We have transparent. Yeah, we will consider, Kumud, we will consider it as a burning candle only. Okay, the object was not drawn like that, but yes, we're considering it as a lighted candle. Okay, so depending upon how much light can pass through any object, we can divide or we can classify the objects into three types. We have transparent objects, translucent, and opaque. Okay, So transparent objects are objects which will allow all the light to pass through it. Okay. So let's say this is a transparent object. Whatever light is falling on it, everything is passed through it without getting scattered. Example, glass. A clear glass is a transparent object, right? Second thing would be a translucent object. Translucent object will allow some light to pass through it. Not all, but some. So some will get partially scattered. So let's say if this is a translucent object, let's say these 4 rays are falling on it, it will only allow, let's say, about 2 rays to fall on it. Rest might just get scattered here and there. Okay, this is a translucent object. Example, a butter paper or a frosted glass, right? And the last one is an opaque object. Opaque object will not allow any light to pass through it. So if this is an opaque object and light is passing through it, nothing will come on the other side. Everything either will get absorbed depending upon the color of the object, or it gets reflected back. So let's say if you're talking about a white table, all the light is getting reflected back. If it's a black table, all the light is getting absorbed. That is how colors work. Do you know how colors work? How do we see colors? Depending upon which color is getting absorbed or scattered, that is what we see. Whatever color is getting scattered away, that is what we see the color as of an object. Okay, so if we are seeing a green plant, that means from the VIBGYOR, apart from the color green, everything is getting absorbed, only green color is getting scattered. That is why we see green plants as green. If it's a white, let's say I'm wearing a white t-shirt, white means all the colors are getting reflected back of the VIBGYOR. So that is why it appears white in color. If it's black, that means all the colors are getting absorbed and hence we see a black color. Yes, correct, Kumud. It is depending upon the VIBGYOR, right? So, okay, based on the same thing, why is the sky blue? Why do we see a blue colored sky? Water seems blue in color because it is reflecting the color of the sky. If you go to a beach or an ocean or you see a sea, no, Bhumi, it's the other way around. Blue is scattered, others are getting absorbed. Okay, so the blue color gets scattered and that is what appears to us, whereas the other colors in the VIBGYOR, that is leaving out the blue, of course, that is the violet, indigo, green, yellow, orange, and red, they are getting absorbed. Yes, blue is reflected. So that is how colors work, right? Any doubt in this, anyone? No? Okay. So they've just given an example of what is transparent, translucent, opaque. Transparent, this is a glass, right? Glass window, let's say. Translucent, maybe a net curtain is put onto the window, so that's translucent. And opaque would be a colored thick curtain that has been put onto the window. Okay. All right. This is what exactly there is, this is a diagrammatic representation of what exactly is translucent, transparent, and opaque. So transparent, all the light is passing through it. Translucent, sorry, this was transparent. Translucent, some light will pass through it, and opaque, no light will pass through it. Okay. All right. So these are certain examples of transparent, translucent, and opaque. We have a pair of glasses, magnifying glass, a glass jar. This is your sand, the clock. Again, this is a candle holder, right? This is a window. Then we have a frosted window. Money, you can sometimes, if you look at it under the sun, you can see through it. And then here we have an ice cream, a cake, a dog, whatever is not allowing light to pass. Even human beings, we are all opaque. Any doubt here? Okay. All right. Let's talk about reflection. Now, this is important because from reflection, then we'll be talking about the type of images that are being found, right? Real images, inverted images. This is what exactly is important in this chapter. So when we talk about reflection, reflection is the phenomena in which light is getting bounced back when it hits a certain surface or it is hitting a certain medium. Now here it is written, bouncing back of light in the same medium striking the surface of any object. Why are we talking about the same medium? Because this I'm sure everybody knows, right? This is a mirror, incident ray, reflected ray. Of course, it will get reflected back. But what is the meaning of this line is that we are talking about the same medium. When we say the same medium, it means, let's say this is in air. Okay. But if I change the medium, let's say if a ray of light is coming into from the air and then it enters the water. When it goes inside the water, it will be reflected in a different angle. Then what will happen? Then refraction will happen. So for now, we are not talking about refraction. We are just talking about reflection. Okay. And when we talk about refraction, that is how your rainbows are formed. That is how you can see different wavelengths of light going into the ocean or into the water. And if you take a glass of water and you observe it under the light, you will see that slightly that ray of light is getting deflected inside the glass of water. So that thing we'll study a little later. As of now, we're just talking about reflection. And the main thing about reflection is that the angle of incidence is always equal to the angle of reflection. That means we take a normal, we take an imaginary line that is drawn perpendicular to the point of incidence. Okay, we don't draw a random line. I can't draw a line here or here. This line needs to be perpendicular to the point of incidence. And then when we take the angle of incidence from the normal, that is I, to the angle of reflection, that is R, it will always be equal. Okay, that means if this is 60 degree, the reflected angle will also be 60 degree. Got it? If this is 45, this is 45. This is 30, this is 30. Okay. Any doubt till here? No. Great. Okay. All right. Now let's talk about how a reflection or an image is formed. So a mirror is a surface usually that consists of a glass and it will reflect the light that is falling on it. How is a mirror formed? We take a piece of glass and what do? How is a mirror formed? You can put it in the chat box. Yes, Arnav. How is a mirror formed?
Ma'am, we take a piece of glass, paint it with silver and paint a red color.
Correct. So basically we silver coat the glass or we silverify the glass and polish it. So basically we are creating a reflective surface, right? Once we create a reflective surface, the light falling on that mirror is getting reflected back. Now it's written that a mirror is a surface usually consisting of a glass that reflects light incident on it to form clear, erect images. That means virtual images or real images or upright images or inverted images can be formed. Here we've written erect image. Erect image means it's a straight image. It's an upright image, right? What is this? What is this kind of image? Is it an inverted image or is it a erect image? Inverted image. Yes, it's an inverted image. So always remember, inverted images are, inverted images are always real images. Or let's say real images are always inverted. And virtual images are always erect or upright. Now, why is this so? So briefly to make you understand, whenever we're talking about a real image, that means the rays of light, the ray of light, wherever it is coming, it is meeting somewhere eventually. Okay? In real life, they will eventually meet somewhere, and wherever they're meeting, we get an image at that point. That is why we're calling it a real image. Okay, and that real image will always be inverted. However, in the case of virtual image, why are we calling it virtual? Is because these rays that are falling on a surface, which is, let's say, a mirror, which is silver coated here on this side, will in reality never meet. Correct. They do not actually meet. We are assuming they are meeting. We assume that they are meeting somewhere. So since we are assuming, that is why we are calling it a virtual image. But we see it on the reflective surface. Why? Because maybe somewhere here they've met, imaginary. And the image can be seen on the mirror. That is why it will always be an erect image. Okay, so whenever you see a inverted image, just simply you have to know that it's a real image. If you see an erect image, it's a virtual image. Okay, any doubt till now? Once we do the ray diagrams, it will become slightly more clearer. Okay, so this is how reflection works. So you can see that this person is reflecting, or a ray of light is falling on the mirror, and then the light is getting reflected back onto this person. Okay, so it has to be in the same medium. Any kind of flat, smooth, polished surface acts as the surface on which the ray of light is striking, and this phenomena is known as reflection. Okay, all right. Now these are certain important terms that you have to know. So basically this particular diagram. So first of all, we have, just one second. Okay, we have the incident ray. Incident ray means the ray that is falling on the surface. So incident ray would be the initial ray of light that is falling on the reflective surface, which is AO. Okay, then reflected ray would be the ray that is getting reflected back, which is bouncing back from this plane surface, that is OB or BO, right? Incident ray will always be in this direction, obviously, because it is falling onto the surface. So it will always be A to O, and reflected ray will always be O to B. It's getting reflected back. Okay, normal is an imaginary line. I've already told you, normal is represented as N or NO. It's an imaginary line which we draw perpendicular to the point of incident. Point of incidence is the point where the incident ray will fall on the surface of the reflective surface. And then we have angle of incidence, that is I, and angle of reflection. So angle of incidence is AON, and angle of reflection is BON. I hope I'm not going too fast. I'm going slightly, because we're just revising. You've already studied this for level 1. That's why I'm slightly going, rushing through this. Anyone has any doubt? Any term that you haven't understood? Yes. Okay. All right. Okay, now let's have a look at this diagram. So in this diagram, or whenever there is point of incidence, the incident rays will always fall parallel to the reflected surface. Now reflective surface, in this case, we are taking as the plain smooth mirror. We're not talking about lenses yet. Okay, so we are talking about the plain surface of the mirror. So there's a plain mirror. All the incident rays will be parallel, fall parallel to the plane mirror, and get reflected back parallel to each other as well. Okay, if the surface is irregular in any which way, then the straight line or the incident ray or the reflected ray might also differ. Then they might not fall parallel to the surface or to each other. Okay, so on a regular polished surface, flat surface, these rays will be parallel to each other. If the surface is not flat, that means in this case where it is irregular, then they can go in any direction. Okay, that is why sometimes if the mirror is not of good quality, you can see distorted images of yourself. Otherwise, you see normal images. And sometimes, I don't know if somebody's been to those, those circus or those puzzle houses where you see yourself bigger, smaller, sometimes distorted, fat, tiny, head is smaller, body is bigger. So basically they're changing the surface for the incidence of the light, because of which you can see different distorted images. Okay, any doubt in this, anyone? No? Okay. Now let's talk about the image formation. All right. Now, like I said, whenever light falls on the surface of the reflective surface, we are seeing the image as a virtual image, and it's an erect image. Okay. So basically, let's say this candle has been placed in front of the mirror. The incident rays are falling on the surface of this plane mirror, and we see it with our eyes. So the light from that object has reflected and gone to our eyes, and that is how we see that object. So the eye sees the image back here. That means inside the mirror. And normally this mirror is erect because it's a virtual image. These rays have actually not met because they will not be able to meet. Eventually, if you try to make them meet, they are going further apart from each other. They are not meeting anywhere. Okay, so that is why it's a virtual image. However, it is a laterally inverted image. That means your left will become your right and your right will become your left. Okay, so lateral inversion is there, but it does not become upside down. Okay, any doubt here? No? Okay. All right. So, all right. So I'm just going to skip through this. We've already discussed how the virtual image is formed. All right. So first of all, whenever an incident of light is falling on a flat reflecting surface, that means a plane mirror, there are different characteristics of the image that is being formed. First, it is always erect. Second, the image will always be of the same size as the object. Obviously, when I see myself in the mirror, I don't appear to be a dwarf or giant, right? I look like how I'm actual in real life, right? So there will be no change in the size of the object. It will be the same size, same height, everything will be same. It will always be erect because it's a virtual image. Third, it is always laterally inverted. That means left becomes right, right becomes left. And the distance of the object from the mirror is equal to the distance of the image from the mirror. So if I'm standing close to the mirror, I can see the image also close to the mirror. If I'm standing away from the mirror, the image will also go further away from the mirror. And I've already told you the image is always virtual. Any doubt in this, anyone? Yes, no? Okay. All right, let's move forward then. This is what I meant by lateral inversion. So let's say if you see mayor written like this in the mirror, it will be upside down. And that is exactly why if you've seen an ambulance carefully, the spelling of the ambulance is written inverted. Why is that? So that when you see it in the rear view mirror, when someone is driving and they see an ambulance behind them, they can read the ambulance in a straight line and then they can allow them to pass through. Any doubt? No. Okay. So it's laterally inverted. The height is same. H1 is equal to H2. Distance is same. A is equal to B. And just that it is laterally inverted. So this is exactly what we mean by lateral inversion. Like I said, it is normally written like this so that in the mirror you can see it straight. This they've written on the other hand. Similarly, right hand becomes left, left becomes right. Okay. Now there are different uses of the plane mirror. Of course, we use it for looking at ourselves. We use it to provide false dimensions to the showrooms. That means if you use mirrors, the light reflected by the mirrors will create an illusion that the room is much bigger than it is actually in reality it actually is. Then mirrors are used in kaleidoscopes, periscopes, and even solar cookers because they will internally reflect a lot of light. So inside the kaleidoscope, it will create a nice effect of the light, whereas in a solar cooker, it will contain all the light. So in the solar cooker, what happens? Internally, the light gets reflected and all the light gets trapped in the solar cooker, which will allow the food to be cooked. Okay. Now this is important. This is something that this is a formula. Normally it has not come for level 1 as of now, but in level 2 it can be asked. Okay. So this is, in fact, I think we had done, I had come across one question paper in which there was in level 1 itself, there was a question on this as well. So when two plane mirrors are arranged along their vertical edge, such that they make a certain angle. That means if two mirrors are placed like this, let's say. Okay, so whatever angle they are making, it could be like this also, it could be like this as well, right? Whatever angle they are making, that angle is represented by theta. This can be of any value. Theta can be anything. Theta can be 30 degrees, theta can be 90 degrees, 60 degrees, whatever. We are just taking theta as a symbol. Okay. In this condition, what will happen? One mirror will act as an object for the second mirror. Why? Because this, whatever you can see here, or whatever light is falling here, will act as an object, and this object will form an image here, right? Yes or no? Or let's say here, this mirror is acting as an object for this mirror. And similarly, this mirror is acting as an object for this mirror. Okay, so the actual number of images that is formed is given by the number n, and the formula is 360 by theta minus 1. Okay, so if this is an even integer, then sorry, this is not a complete formula. This one we use if this one is an even integer, that means we will take -1, and we will simply use this if it's an odd integer. Example, what do you mean by odd and even integer? Let's say 360, theta is 30 degrees. So if you put in the formula 360 upon 30, what will be the answer? Is it odd or even? 360 by 3? Is it odd or even? Odd. Okay, even. It's even. What is the answer? The answer will be 12, right? So if it's an even integer, that is 12, we will subtract 1 from it. It becomes 11 images. So the total number of images that will be found would be 11. Now, if it's an odd integer, then simply we will not do anything. Let's say it was 360 upon, let's say the angle was 90. Then what will happen? Or any which way, forget about the theta. Let's say 360 by theta has come out to be 11 altogether. Or let's say the 360 by theta has come out to be 9. Then we will not subtract 1. We will leave it like that only. So in any which way, the number of images even, 0 would be even, but 0 wouldn't be the case, no? It cannot be 360, it cannot be 0 in any way. If the angle is 0, that means they are parallel to each other. Then the number of images doesn't make sense. Then the number of images would be 0. So number of images always will be odd number. So to make it odd number, if this is an even integer, we will subtract 1. If it's an odd integer, we will not do anything. We will keep it like this only. Got it? Any doubt, anyone? Let's move forward. So this is exactly what we were talking about, right? This is how the two mirrors are being placed. And if you place an object, normally this object, this, depending upon how many reflections and what is the angle between the two mirrors. So more or less here, if you see, it's more or less 90 degrees. So what will you do? You will do 360 by 90. Then you'll figure out whether the integer is odd or even. So whatever you get, if it's an even integer, you will subtract 1. If it's an odd integer, you will let it be. And that is the number of images that you will get. Got it? Okay, great. All right, so I'm just going to go through a few slides and then we'll do some question answers. All right, I'm not going to do the eye. I'm just going to just talk about, just let me just stop sharing my screen. I'm just going to start with the question answers. So the practice questions that have come in the previous year of Level 2. So what I want you to do is read the question carefully, put your options, whatever you feel is the correct option, put it in the chat box and send me a direct message. Don't send it to everyone so that everybody gets a chance to answer. Is that okay? Send me a direct message if you want to answer. Okay. Which of the following are virtual images? The image formed by an image projector, the image formed by a plane mirror, the image formed by rear view mirrors in automobiles. So the options are 1, 2, 2, 3, 1, 3, 1, 2, 3. Okay. Abir correct, Shakti correct, Shri correct, Bhumi correct. Think about it. Shriram correct, Aliza correct, Nehira, Yashika, think about it. What is a virtual image? If it's a virtual image, it will always be erect. So out of the following, the 3 options that have been given to you, where do you get erect images? The rear view mirrors in automobiles don't give you erect images. Achintya. Huh? You see the car upside down. If I look at the rear view mirror, do I see an upside down image? No, right? Image formed by a plane mirror is definitely correct. Image formed is always erect. What about the image formed by an image projector? It's a real image, correct. The images are usually inverted. So if you see it in the projector, it is an inverted image. And then when it plays on the screen, it becomes usually inverted. And that is why it is not laterally inverted. Okay, otherwise, whatever movies you're seeing, if the actress is putting up her right hand, we would see the left hand. It's not the case, right? It's a real image in the projector, but then when it's played on the screen, it is inverted again so that you see the actual presentation of whatever is happening. So the correct answer here is only 2 and 3. 2 and 3, that is the plane mirror and the rear view mirrors. They are both virtual images. Okay. Next, a concave mirror is used to form a real image of a candle. If the upper half of the mirror is covered by a piece of paper, then the image becomes dimmer, the image remains the same, the image becomes brighter, both A and B. I know we've not spoken about the concave and the convex mirror in the demo, but I'm sure you know of it. We had that much time only, but when we come to real class, like when we come to the session, we'll be doing everything. But as of now, I wanted to answer the question. Concave mirror. What is a concave mirror? How does a concave mirror look like? The reflective surface would be curved, right? Now I'm covering the upper half of the mirror. So this part of the mirror is covered. So what will happen? The image becomes dimmer, image remains the same, the image becomes brighter, both A and B. Bhumi correct. I'll just see who all have answered. Bhumi is correct as of now. Shriram correct. Yashika correct. Rest, nobody has answered yet correctly. Abir incorrect. Rest, nobody has answered correctly. Only 3 of you have answered correctly. Okay, if I cover, yes, Abhi, now it's correct. Yes, Shri, correct. Even if I cover half the mirror, does it affect the reflective surface? The reflective surface remains the same. I am just decreasing the size of the mirror. Let's say if I have a small mirror in my hand and if I have a full length mirror, will the nature of the image change? No, right? If I have a small cosmetic mirror or a big full length mirror, it doesn't matter. So the image remains the same because the reflective surface is the same. We are not changing the reflective surface. We are just changing the size of the reflective surface. That doesn't matter. That will not affect the image. Got it? So the correct answer is B. The image will remain the same. Okay. Next, Isha obtains a blurred image of an object on a screen by using a concave mirror. In order to obtain a sharp image on the screen, she will have to shift the mirror dash towards the screen, slightly away from the screen, to a position very far away from the screen, either towards or away from the screen, depending upon the position of the object. Okay, I'm just requesting everyone, can you put the question number as well, like 3 and then the option 3, D, B, whatever you want to put, because then so many of you are answering, it gets confusing. Okay. Shri is correct. Abhir correct. Shri Ram, think about it. Yashika correct. Arnav correct. Bhumi, think of Nihira correct. Bhubi, think about it. Shakti, think about it. It's a concave mirror again. This is the curved reflective surface. Whatever is the object she's placing, Isha is placing, is giving a blurred image. What does she do? Does she put it towards the screen, away from the screen, to position very far away from the screen, that means to infinity, or whatever? She can move it around depending upon the position of the object. Yes, Sriram, correct. I'm giving you 2 more minutes. Aradhya, correct. Yeah, and why are everyone's videos off? We'll be meeting for 1 hour, 15 minutes in the regular sessions. If you get tired after half an hour, that will not work. You'll have to switch on your videos, please. It's nice to see some faces on screen. Otherwise, you'll get bored of just seeing me on screen every day. You will be meeting 4 times a week. It'll slightly get boring just to see my face. Okay. Yes, quickly, whatever's coming to your mind, what do you think will happen? So if it's a concave mirror, it can give images, or it can give a sharp image depending upon where it is placed. Whether the object is placed on the normal, is it placed on the focal point, whether it is placed away from the focal point, whether it is placed at infinity. So you don't know the size of the object. You don't know the actual position, right? They've not mentioned the actual position. So simply the answer would be simple, either towards or away from the screen, because initially they've not told you where the object is put. If they would have mentioned that, let's say the object has been put at the focal point, then you can say that it is moving forward or backward. Okay, but they've not mentioned anything. So the simplest answer would be either it moves towards it or away from it. We don't know the actual position of the object as of now. Got it? Right? Okay, next. Okay, in the given diagram, where will you find the image of the pencil? A, B, C, D. It's a plane mirror. Image will be seen where? 4. Nobody's given me the correct answer. Where will you see the image of the pencil? Image of the pencil. It's a mirror, plane mirror. No. Nobody's given. From which angle? Okay. From which angle? I'm observing it from here. Or let's say I'm observing it from here. I'm looking straight into the mirror. Pencil is placed like this. This is the mirror. Pencil is placed like this. I'm looking right in front. Where will I see the image? Achintya has answered now. Correct. C. Option C is correct. Wherever I look from, if this is a mirror in front of me. Let's say this is the mirror in front of me. Okay. And I can see an object from here. Image, so I'll see straight only, no? The pencil will not be curved here or here. Image will always be straight. Yes or no? If I'm standing in front of the mirror and I'm seeing somebody at the back, try this at home. You're standing in front of the mirror and somebody's passing at the back. Will you see the image of the person bent like this? Like in the corner or somewhere here in the corner? No, you will see right it in the mirror, straight in the mirror, right? Wherever you are standing, according to your position, the mirror will be showing you the image. So it will, no matter where the object is being placed, you will always see it straight into the mirror. So it will be C. Even if I was placing it here, the pencil, it will be at C only. Got it? This way, this way, this way, mirror will always be straight. Okay. Any doubt as of now? Anyone? Okay, fifth question. Which of the following forms virtual and erect image for all positions of a self-luminous object? Self-luminous means luminous object. Always forms a virtual and erect image. Convex lens, convex mirror, concave mirror, or both A and B. Always a virtual and real, erect image, not real, sorry. Correct. Bhumi correct, Shriram correct, Pranav correct. Abhi, think about it. Neera correct. Shri correct. Correct, Abhi. Yashika correct. Yes, what about others? Yes, Kumud, correct. Okay, so most of you know the correct answer. Aliza, think about it. Aradhya, take a second guess. Virtual and erect image is always formed by a convex mirror. No matter where the object is being placed, a convex mirror will always form a virtual and an erect image. The image formed in a concave mirror differs depending upon the position of the object. So it can be a real or an erect image, real or a virtual image, depending upon where you place the object. Even convex lenses for that matter, but a convex mirror will always give you a virtual image. And if it's a virtual image, it will always be erect. Simple. Okay. Next, the given diagram shows the splitting of white light into 7 component colors when white light is passed through the pigment. Which of the following options lists the colors of the marked rays? So it is simply what? Your VIBGYOR. This is the easiest question of the lot. White color is always split into a VIBGYOR when it passes through a prism. And that is exactly the principle of the rainbow also. So they have marked 1, 2. They've left 1 in middle, 2, 1 in middle, 3, 1 in middle, and 4. So you have to tell me the correct option. First is what? And okay, Aliza is correct, Kumud correct, Radhya correct, Shriram correct, Nihira correct, Achintya correct, Shri correct. Rest all of you, Nirmalya correct, Rudransh correct. Think about it. Is it VIBGYOR or is it VIBGYOR like this? Do we take the VIBGYOR like this or in this position? Is it from here or is it from here? That is the only difference in your answers. Okay. Okay, what is VIBGYOR? Violet, indigo, blue, green, yellow, orange, and red, correct? They have marked these. You have to tell me these, right? Now, usually the most scattered one, this is the one which is most scattered, right? If you look at the angle of scattering, this is the maximum. Which is the color that is getting scattered maximum? That is violet. That is why the sky appears blue in color, because it is maximum, it gets scattered, and red light scatters the least. That is why your stop signs, the red light is red in color, because it can travel through a long distance in a straight line. And even if you're at the back of the traffic, you can see the red light from a great distance. So the VIBGYOR is VIBGYOR. Okay, so the correct option would be C. Got it? Yes, Bhumi.
Ma'am, can you please explain this question once again?
Okay. So this is white light that is being split into VIBGYOR, right? Now, how do we know that is it from here VIBGYOR or in this position VI? Okay, that is because blue color or violet color gets scattered the most. Why? Because it has the smallest wavelength. This one is the minimum wavelength. What is wavelength? Wavelength is the length of the light ray. Simple. Because we've already established that light travels in either the form of a wave or a particle. So when it is traveling in the form of a wave, whatever is the length of this wave, that is known as the wavelength. So blue light has the minimum wavelength and red light has maximum wavelength. So since it has maximum wavelength, it can travel long distances, right? So when it is traveling long distances, even when it is passing through a prism, it doesn't scatter that much. So if you see, this is the incident ray and the angle of the incident and the angle of this number 1. Okay. So this one will be the least scattered. So it can travel a long distance and the most scattered would be violet. Yes. So Sriram is asking me that if violet scatters the most, even more than blue, why is the sky blue instead of violet? Violet gets scattered a little too much. So that is not visible to our eye. Certain wavelengths are not visible to our eye. Example, certain fluorescent colors are not visible to our eye directly. That means fluorescent colors are also luminous. They also impart a color. But until we see them very closely, they don't shine as much. But if we add fluorescent to something and then we reflect light on it, and can reflect back a lot of light. That is on your cycles, on your bikes, on the tires, and sometimes even on the helmet or the reflective jackets that we have here. They are all fluorescent in color, shiny. So when you put light on it, then it gets reflected back at a great intensity. But normally they are not visible to our naked eye. They might be visible to other organisms like dog and all. So maybe for the dog, so dogs, of course, they have black and white gray scale color. But if they did have color in their eyes, they might be seeing the sky as violet, but we are seeing it as blue because that is our perception of that much wavelength only can come to us. Got it? So that is why it appears blue. So blue is somewhere in the middle, like here. So sometimes we do see the sky, like if it's a clear day or a clear sky, or if someone not, of course, not very clearly in India, but if you're outside somewhere and then it's not cloudy, it's a clear sky, we can see an indigo sky or a very dark blue violet sort of a sky. It all depends upon the scattering of light. Any doubt here? Bhumi, understood? Okay. All right, next, which of the following properties of light are made use of in the periscope shown here? So this is a periscope. Light travels very fast. Light can be reflected. Light travels in a straight line. So in a periscope, mirrors are placed here. So if you have an object here and you're looking at it from here, you simply see the image nicely. What are the characteristics that are being used here? Correct. Nihira correct. Ishika correct. Veer correct. Nirmalya correct. Arnav correct. Shakti correct. You are correct. That is, one, light can be reflected. That is why these mirrors are being used. And light travels in a straight line. So it's just getting reflected and following a straight path. Driver sees in his rearview mirror the image of a truck parked behind his car. The speed at which the image of the truck appears to approach the driver will be dash. There's a driver reversing the car at the speed of 4 meters per second. There's a parked truck behind. So if the car is moving 4 meters per second, in the mirror, the truck is approaching, or the image is coming closer at what speed? What a tricky question. Most of you have got it. Okay. Okay, Rudransh, correct. Bhumi is correct. Shakti, correct. Aliza, think about it. Shriram, Abhi, think about it. Arnav, think about it. Bhumi, you're correct. Kumud, slightly think. It's a rear view mirror of a plane, rear view mirror of a car. It's the plane mirror. It's not convex, it's not concave. Driver is reversing at the speed of 8 meters per second. Okay. All right. Whoever answered correctly. Yes, Aradhya, you have a doubt? Okay, one second. Let me see who all have answered correctly. And I will just pick out one of you to give me the explanation. Okay. I think I've seen. Okay, Rudransh, can you explain why did your answer is correct? Can you explain how did you come to that answer? Rudransh, can you hear me?
Yes, ma'am. Ma'am, it is there when, ma'am, it is like in the rear view mirror, when anything is coming there, the speed, if the speed of the object in real is v, then in the mirror it will be 2v.
Correct. So to calculate in the rear view mirror, the speed is always doubled. Okay. So you just have to remember the formula. If the velocity of something that is approaching is, if the object is v, in the rear view mirror, you can see it as 2v. That is mainly to create precaution in the driver. Normally in a normal plane mirror, like the mirrors that you have at home, that doesn't happen. It's not that you start running towards the mirror and your speed will increase in the image. No, that has specially been created in the rear view mirrors so that the driver becomes cautious that the car is coming. So when you see the car coming towards you, it usually is not coming at that speed. It is just half the speed of what you can see in the rear view mirror. So you have to just remember the formula. The object v is equal to twice v of the image. Got it? So it will be 8 meters per second. Okay. Right. Okay. This is the last question that we'll do. David is observing his image in a plane mirror. The distance between the mirror and his image is 6 meters. If he moves 1 meter towards the mirror, then find out the distance between David and his image. David and his image, not the mirror and the image. Yes. Yes, all of you are correct. Arnav, think about it, except Arnav, others are correct. Whoever's answered are correct. So what we're doing, this is the mirror. Wait, let me draw a straight line. This is mirror. Here David is standing and he's moved 6 meters. So 6 meters he was initially, okay, sorry, 1 second. I'll draw mirror in a, yes, this is the mirror. David is standing here. The distance between the mirror and his image is 6 meters. That means mirror and the image is 6 meters, right? Now he has moved 1 meter ahead. So now the distance between, this will also move 1 meter ahead, correct? So this becomes 5 meters. And David has also come at 5 meters. Yes or no? So they're asking, find out the distance between David and his image. That is option D. Okay, 10 meters. So sometimes you might know the answer, but in a hurry, you might just not read the question properly. Okay, so that's it for my side today. I hope you all like the demo and hopefully I'll see all of you in the real regular classes. Okay, any doubts, anyone? Of course, we will be doing many more questions. We will do a revision of a topic and then we'll do the question answers like we did today. Right? All right, thank you everyone. Have a great day. Bye-bye. Welcome, bye-bye.